So this is Embedded Systems, lecture number 20. We just had a quiz where we talked about the concept of a dishwasher. So write a state diagram for a dishwasher that has the following input buttons, all right? Now again, we are talking that this is a bit ill-defined because the expectation is that the first 4 buttons up there actually start something. But the next one is going to be a red input. All right? So from this respect, since we say the first 4 buttons will start something, what will most likely that button be tied to inside the microprocessor? An interrupt. Most likely it will be tied to an interrupt. Not necessarily all the time. For example, your idle state might be sitting there just checking the buttons again and again and again. And one of them finally come in, then you start. Kind of a waste of electricity there. So in this case, you would have, if those generated an interrupt, all 4 of those could be tied to your interrupt line that goes inside your microprocessor. And then as a part of the functionality of that interrupt service routine, remember we talked about an interrupt service routine earlier? I did talk about that, right? Okay. Then it would check to see which button was actually pressed, and then start that specific state. But again, all of that is that you're going to go from an initial state, you're going to go to a new state, whether it be long wash, short wash, or rinse. And then after that, depending on what the input is, it will either go to the dry state or it will go back to idle. So that's about all I was looking for. And again, up here, the example I gave you, make sure you put the initial state, you know, the red line up there, so that will be a minus, probably 5 points out of the 10. Meanwhile, she's like, ah! And actually, if I were to look at all of these here, I'm sure I would see more than that, just that one. Oh, let's see, this is not. Now I'll do this. All right, so, oh, well, wait, that one has one. And, that one. I looked at, whoa. That might be a little bit too complex. We'll have to look at that. I don't see the initial state designator, right? Somebody needs to check their spelling. There we go. There's a nice initial state. And did I have one in here that didn't have a name on it? Is that missing a state, initial state? That one has it. This one does not. So again, very important. Very important. I like it. Button selection, no buttons pressed. Now here's the interesting thing. Here's one. Technically it's right. Alright? Or at least I think it is. I didn't look at it in great detail. But notice it is a bit complex, right? So here's one aspect of this, is that we are going to actually go through exercises and we're going to go through reviews of how you go about it. In fact, that's going to be one of the future lectures, is how to go through peer reviews. Have you had that yet in your any of your design courses? No? Which one?
Senior design.
Senior design, that talked about how to do a peer review, or that you should do it?
Well, we had to do one just recently.
Oh, but that wasn't a peer review, that was a presentation, right? The faculty?
We reviewed each other.
Oh, you did?
Yeah.
Wow. Not in front of each
It was
other?
like an online one.
Oh, just online. Yeah, we're going to do an actual peer review, and that is rather interesting. If you have not done a peer review before, how many of you have actually done a peer review with somebody else? All right, in industry, right? In industry.
Yeah.
In industry. All right. Very common, extremely helpful, but again, some people get very offended. All right, so a peer review means that you will have somebody actually go through and review your work. And in fact, I'll tell you what, I'm going to do one right now. Who here would volunteer to do a peer review of their design, and for the reward for you to do this peer review, we will give you full points on this quiz. So, any volunteers?
Are you talking about the quiz? Yeah, the quiz.
The quiz we just did now.
Yeah, you can do mine.
Is this yours?
Yeah.
Really?
Yeah.
You want a 10 on this quiz?
Sure.
All right, we're going to do a peer review on this. So, can everybody read this, or do I need to zoom in some?
This is Paula Comp, right?
Yes.
All right. Somebody want to do the same one?
All right, so here's how we would start a peer review. So in this peer, Paul, you're going to need to come forward because we're going to need to record your voice. So I'll tell you what, I'll give you a 10 on this quiz and a trip to the prize closet.
Woo! The next contestant!
I need to have one of those little badges that say that.
All right. So today we are reviewing Paul's design for a dishwasher system. As a part of this review, remember that we are objective and we're to identify everything associated with this design. So to begin with, Paul will give a description of his design. He'll spend 1 or 2 minutes on it. Okay, go ahead and do it up there so at least they'll hear you. Because my voice is booming. Your voice may not be so booming. All right, go ahead.
All right, since we're doing a dishwasher, we're going to start in the idle state. And my dishwasher at home has a lock button. If you don't have the lock, nothing happens. So I had a lock. Then you go to the button selection. If no buttons are pushed, it's just going to keep looping in that state. If you did the long wash, it would move to the long wash state. After so many minutes, it'd go to just a wash state. Then after so many more minutes, it'd go to the short wash. I'm thinking of it like a dial instead of buttons, I guess. Then go down to rinse. If they push the air button, then it would just skip the heated and just go all the way back to idle where it would wait for you to take out the dishes. If you push wash and at the button selection, it would have went to wash. If you push short wash from the button, it would have went there. Rinse, then heat. If at any time you hit the unlock, it would go back to the idle state and you'd be able to unload for whatever reason you unlocked it for. Because I know I've done that before. Like I found extra dishes, so I had to unlock it.
All right. So based on this description of this design, would anybody like to make some comments or suggestions about this design? Yes, sir. Speak loudly as you do it, by the way.
With the 3 washes being directly in a row, I would assume going from your idle state to wash, it would be filled with water. That's my only concern. So every single time, again, trying to fill with water.
Okay. So is the assumption at any time during this that you're actually emptying water out?
I guess no, because I'm thinking of the dishwasher I have at home where it is an actual dial and I can either go from long wash to or short wash and it will stay in the same thing. So that's how I pictured it. So I guess the water would stay in there the whole time.
Okay. So that might be a something that we need to work on, right?
Right.
Okay, so let's take a look at that. I do have one question since nobody's volunteering to raise their hand. If you unlock, you go directly to the idle state, but as soon as you lock, from what this says, you go to the button selection state, and then supposedly it sends you back to whatever state you were in. However, in that case, what does it do with the water levels, and what does it do with anything else associated with the entering a state for the first time?
I see. So I needed a drain state over here, and then an idle. Is that what you're saying? And then I guess when you lock it, fill it back up. Then
Well, maybe one question would be is if you have a lock, are you actually leaving the state or you're just temporarily suspending all activity until it's relocked?
I guess you'd be suspending, but you'd have to drain the water.
Oh, do you?
Well, if you're gonna open it up, you have to drain the water, so it must be.
Do you really? So in most, actually in most dishwashers, the water never goes above the bottom pan. And so you can open and close it at any time with no problem. And this is maybe something that we need to identify more from the specifications, since our specifications are kind of vague, aren't they?
Yeah.
All right, so we'll have to look at that. Any other comments here by the review?
What's the heat again? The heat state?
Oh, what is the heat state?
If you wanted instead of having an air dry, it heated, so it would dry the place.
So you add yourself the one extra.
Yeah, I added my own state.
Okay. Now, one question about this is that we never actually included a lock button or a lock device here. So, actually, from the true specifications, there shouldn't have been a lock in there at all, because that's actually something not in our requirements and such. So, is it possible you could redo this without the lock?
Just remove the lock.
Okay, so, yeah, we're gonna have to review this again. So when we do this design review again, you'll need to, take this out. Now you are doing the minutes for this, right? The answer is yes. Yes. All right, so, our secretary, or our recorder of the minutes will, actually, provide the minutes for this review and take, he has taken all the, suggestions here. If you could make sure to, put those into place, and then we'll re-review this at a different time.
Okay.
Sound good?
Yep.
All right, thank you very much.
Thanks.
All right, woo, all right. So, what was that worth, all the aggression to get a 10 on this quiz?
You get a 10.
Oh, okay, good. So let's see. 10 of 10. There we go, 10 of 10. You are the winner. Woo! All right. So, in the case of this review, what we did is we actually did a mini type review. Usually what would happen is somebody would provide written materials, everybody would review it beforehand, they would come with their questions already to ask, there would be some discussion. I had a manager once who, a second level manager, and he says, you gotta be really careful because Paul took this really well, even though we found problems. But there are some people who just do not handle criticism, even if it's constructive or observations, because nobody wants to be told that their child is ugly. And literally, that's what my manager says. Nobody wants to be told that their child is ugly. And I actually when I worked at IBM, I shared an office with somebody who just did not have the right, we call it bedside manner, or the ability to talk to people about a design, and usually there would be yelling involved with this design reviews, and so that's usually not a good thing to do. Because in the end, doing design up front, imagine this, if based on this design that we saw, if he actually implemented the software, and notice we found a couple of problems in there that he needed to address. He would be spending a lot of time doing design when, for example, the lock feature wasn't a part of the product. And even though it's nice, it's not part of the product. And he had the right, at least the attitude that I had for the air dry button. But what if somebody else did? Then they would have to do that rework as well if they were looking at it before the design review. And so that's why you have people do design reviews up front. All right? That was an interesting experiment, wasn't it? Let's go back to our previous problem. Man, is this thing loud or what? If I could turn this down a little bit. Are we lower? That seems just as loud, doesn't it? there is one way I could fix this. Let's see if that did anything. Are we just as quiet? Did this go down a little bit? I think it's not as much feedback as before, right? Okay, so, if you remember, this was our design for the snack food machine, right? So we need to take a look at this in particular, how it's going to be associated with software. All right, so we have our design here. Now, keep in mind that one of the things we want to do is identify how we move from one state to the next. So what we're going to do is identify the architecture of our system. So in our architecture, we're going to identify the main subroutines that we'll be using, all right? So let's take a look at some of our inputs, all right? What are some of the inputs that we see? Well, here's the return button, right? Well, let me step back a little bit and let me identify this. What activities will identify an interrupt? And I think we already said that, right? The shake, the return button, the inserting a coin, the button selection, the drink sensor, and the stock level. Well, not the stock level, the drink sensor, right? We'll all identify if it's going to be some sort of a interrupt-based input. Now, when we're working with interrupts, we have something called an interrupt service routine. Does anybody not know what an interrupt service routine is? Be honest, because otherwise I'm going to cover it. All right, just one person doesn't know what an interrupt service routine is. Good, I'm going to quiz everybody who's not raising their hand. Let's see. This gentleman in the gray, yes. You know what it is?
Yes.
Okay, tell us.
It's, so when an interrupt occurs, whether it's external or internal, it's a routine that runs and then returns back to where it was before.
Okay, good. So it is some sort of routine that will return to the previous state. We give an example in the book. Did anybody actually read the book? I'm going to give a quiz on the book next time, all right? So let's do something really quick. Let's say a real life example. I am going to clean my house. All right. So in my example here, rather than start with architecture, I'll start with just a basic interrupt. I'm going to clean my house, and in the process of cleaning my house, I might actually get a phone call. Or I might get somebody who will ring the doorbell. Okay? So, my interrupt is going to be as follows. So I'm going to clean. Clean. I'll do my cleaning. Then I'm going to get a phone call. So what I will do is I will service that phone call. And as a part of servicing that, what am I going to do? Well, I'm going to answer and talk and hang up. And because I'm a very simple person, I cannot clean and talk on the phone at the same time, right? And then once I'm done, I will actually return to do the exact same thing that I was doing. So I'm cleaning, and maybe at this point I was dusting. So, I will continue on cleaning. Now let's say somebody rings the doorbell. And so I will open the door. I will yell at the religious person who wants me to convert to their religion. And then I will close the door. I'm sorry, I won't yell at them. I'll just say, talk to. And then I will close the door. And then I will go back to the exact same place as I was cleaning. I'll just probably yell because I was being interrupted and I don't like being interrupted. So, this is the equivalent. In the computer terms, this is your regular processing. And these are interrupt service routines. And these are nothing more than just regular C functions that have been identified as an interrupt service routine based on work that you had to do. Now the interesting thing about this, and this should have been covered by all of your previous classes, things like architecture. And I know the engineering technology students had it because they've actually done assembly language programming. So what's happening is you suspend at this point your regular processing and you save all of your current state of what you're currently doing. And then you basically change the program counter to whatever this interrupt service routine is. In the process of the interrupt service routine, it may change variables. And remember, we know the difference between local and global variables, right? So obviously, what must be changed in here? You change global variables. Because if you change local variables, as soon as you finish the interrupt service routine, it's all gone. And nothing is saved. And the whole idea of entering an interrupt service routine is to actually do something with the global variable. So again, the whole reason for interrupt service routines is to change global variables. So what's one type of global variable do you think would be really valuable to have that interrupt service routines could change? How about one that we've been talking about for the last day and a half?
Reset?
Yeah, I heard it up here.
Oh.
Flags, or more specifically,
It's a button.
what state you're in, right? So you should have some sort of state variable that identifies, oh yeah, I am in the idle state, I'm in the validation state, I'm in the dispense state, I'm in the change return state. And maybe something like pushing the return button will actually go to an interrupt service routine where you'll say, if your current state is money inserted, then change to the change return state, else just exit, right? Because what if you're in the change or return button state, or what if you're in the alarm and lockup and somebody presses the return button? Just ignore it, right? What if you're in the dispense and issue change state and somebody presses the return button? You want to ignore that, right? What if you're in the validate state? That's interesting. Maybe that's a question we could see. You want to stay in that state? Do you want to ignore it? Or do you want to go to the change returns? Ooh, that's why we go back through here and review everything. And that's kind of like what you would find when you start architecting your system. So, let's assume that we're going to have a state out there, or a variable out there that tells us what the state is. And now we're going to create some interrupt service routines. And we're going to identify what functions we need and what interrupt service routines we need. So what I want you to do is we're going to pause for a little bit, and I want you to think about all the different interrupt service routines that you might need. And as a hint, I'll pull this back up here from the previous class, all right? So let's take a pause for the video, and between you and your neighbor. All right, now we're back, and you've had a little bit of time to work on this. Those of you in TV land, hopefully you did some work on this as well. So, what could be one of the first sensors that might generate an interrupt? The accelerometer? All right. So let's create an accelerometer type of ISR. Here, I'll call it theft possibility ISR. And of course, they're all void. By the way, I'm not writing code, but I'm going to write a design. So if we have this, what are we going to do? What if we set anytime you have an accelerometer sensor, theft possibility? All right? So we're going to set the state equals to, it says an alarm lockup. So I'll just call it alarm lockup. And, oh, by the way, we never did determine how we go back to the idle state, did we? So what do you think we should do? You want to start a timer? All right, so we'll put a timer here. And we'll start that timer. How about that? All right, well, that's one of our main functions. What's another one?
Disable all the other interrupts.
Oh, hold on, you just said something so fast I didn't understand.
Disable all the other interrupts which are not required.
Okay, do we really want to disable all the interrupts?
Except timer interrupt, the other interrupt will be disabled because suppose anybody presses some other button, it will go to that state.
Well, is that a bad thing?
Yeah, if it is in the lockup mode, it should not go anywhere else.
All right, so you're saying we should disable interrupts. All right. Disable button interrupts. It could be a certain level of interrupt. For example, buttons might be low priority and timers might be really high priority. Okay? What about another interrupt service routine? All right? So this would be the return button, right? So we'll do return button ISR. And when do we really want to acknowledge the return button?
We have the first part state.
All right, well, do we worry about the return button when you're in alarm and lockup?
No.
No. How about when you're the dispense and change? It's too late by then. What about the idle state? Do we really care about it then?
No.
All right. What about the validate state?
No.
I'll tell you what, let's ignore it in this state. How about that? Makes life easier. What about the change return state? Well, you're pretty much already in it. So the only state you really care about is the money inserted state, right? So we can say, if, let's see, if state equal the money inserted state, so if state equals money inserted, then
It must also check the other condition.
let's use a change return. So, what if the state is not the money inserted state? That means you ignore it, right?
So it has all, it must also take another condition stating that if your money input is equal to the price of the product, then it must not go into the state. If the money inserted is more than, then only it must go to the state.
Well, here's the question. If your state is the money inserted state, right? That means you put at least something in it. But it could be a whole bunch of money in it, right? Do we care? This is a simple machine. Not really at this point. You're talking something that might be you might be in the middle of something. We'll take care of that a little bit later. All right? So, is there anything else we need to do here? All right, we'll call this done. What's another interrupt type of event that could happen? Visiting back on here, we took care of the accelerometer, right? We took care of the coin return button, right? How about another one? Coin insert, right? Everybody knows why an ISR is void, right? Because it's not a called function from another C function. So there will never be anything you pass into it. Everything is going to have to be observed from out there. So coin inserted. Now here's one thing I want you to notice. Very little processing going on in these ISRs. So you usually put very little processing inside. What did we do here? We set a variable, we started a timer, we disabled interrupts, button interrupts. Very low level, right? If something was there, we just changed a variable, a global variable here. So coin inserted ISR, and I'll help with this one. If not a valid coin, return coin, return from this function. Otherwise, we'll call it the state equals money. Oops, what would we call this? Money inserted state. What if you are already in the money inserted state? You just stay in the same state, right? And anything else? Oh, maybe we should do this. Save coin value and whatever the coin inserted value is. Notice we're not adding it yet. Now we could set this up that when it enters in an ISR, that it doesn't allow any other interrupts to occur. And that's called disabling interrupts. So as a simple example of disabling interrupts, perhaps I was, somebody rang the doorbell and then the phone rang. I would say, I will not try and answer the phone while I'm talking to somebody at the front door. That would be disabling the phone interrupt. All right? Did we have any other one? Oh, we had that, this theft timer, right? I bet you the theft timer should be some sort of ISR, right? So, if that happens, what should we do with the state?
It must be the same thing.
Go back to idle? So, if you were putting in money, and then you shook the thing, I would say it served them right. We're going back to the idle state, they don't get their money back. So there. So it would really stink to be them if they put money in and an earthquake happened. And then, you know, things settle down and they wouldn't get their drink. So this may not work in California, but it's for here. Do you have a question?
What if the opposite happened? Someone shook the machine left and someone else inserted the money? You also
Yeah, we could set it up such that if you're in the alarm lockup state, then all button presses and all coins just are ignored. The coins just fall back out. How about that? You like that? We'll do that. So, any other interrupt-ish type activities? Let's look here. We got the coin insert. Oh, look at that. You said the button selection, right? We would do that. So we need to do the button selection. So this would be the button selection ISR. And as a part of the button selection ISR, what would happen? Well, what if you're in this idle state and somebody pressed a button? What should happen? Nothing, all right? What if you're in the change return state? Really, nothing happened, right? What if you're in the money inserted state? Oh, that's when you want to go to the validate state, right? What if you're in the validate state? Well, they've already pressed the button, so it's too late. They can't change their mind. Dispense and change? Oh, they can't change their mind. Alarm and lockup? It's ignored. So it obviously looks like if the state is equal to money inserted, then the state will be equal to the validate, right? And oh, by the way, we'll leave it this, we'll save the button press. So otherwise it's ignored, right? Can you think of any other ISRs that we haven't addressed yet? Let's see, we got this one. Drink sensor. I think you all wanted to make sure that you had a sensor for this drink, right? Sensor of drink. So this would be the drink sensor of drink. All right, sensor of drink ISR void. So what's going to happen? What's the main thing that's going to happen when we're sitting in this dispense and change? Well, if it senses the drink, we'll go to the idle state, right? So obviously the state is going to be equal to idle. Wow, that's a lot of work, right? But there's a whole bunch of other stuff that goes on. So let's take a look at what usually happens in some sort of embedded system, right? So now we've addressed ISRs. Next is what? Our main loop, right? Whatever runs, usually. It's not what runs in the idle state, it's what runs everywhere else. So how do you always start how the main program is going to run? So do forever. And what you will do is, based on some sort of switch, on whatever your state is, you're going to do different things. For example, if you're in idle, what will you do? Well, you'll do whatever the idle state function is, right? What's one of the other states that we just created? Well, let's list them all. We have the money inserted. We have the validate. We have the dispense and change. We have the change return. And we have the alarm lockup. These are all different states that we're going to be running, and we're going to be doing things in each one of these states. So obviously, we're going to have a different function for each one of these, right? That you'll call. And obviously, you're going to have to identify each one of these functions to do something. So let's take a look at, what's a good one to look at? Oh, alarm lockup function. All right? So there will be one here at the alarm lockup function. Let's do that one. Now, is the alarm lockup function interrupt service routine? Yes, no? Are you sure?
It's not an interrupt service routine in this case.
All right, it is not an interrupt service routine because we've already created it with an interrupt service routine, right? Or we've already identified that there is a problem right here. We changed the state to alarm lockup. And as soon as it returned from the interrupt service routine, and it came to this state, it's going to do it, right? So in the alarm lockup routine, what would we want to do? Well, we'd probably want to do stuff like lock bottle drawer, whatever that is. Dispenser, coin. What the heck, sound alarm. And, I don't know, activate the taser. Yeah, I look at all the US guys saying, oh yeah, tasers are the answer, man. And there might be a couple more other functions that you might want to do. So I'll tell you what, we're going to continue this conversation at the next lecture. Thank you very much.